Welcome to Math and Computer series by Java. We're going to be talking about factorial in mathematics, and as always, we're going to try to translate the factorial of n into Java programming. So our first agenda of the day is factorial of n. So what is factorial of n in mathematical terms? It is denoted by n, which is number. Next to the number, it's an exclamation point. N has to be a positive integer, so there won't be any negative number or decimal number. So to put everything in one sense, it's a product of all positive integer less than or equal to number n. And there are two examples below. It will show you what it actually means. So 4 factorial would be 1 times 2 times 3 times 4, which is 24. 5 factorial, again, it's 1 times, 2 times, 3 times, 4 times 5, 120. So in theory, it's very simple. All you have to do is you just keep on multiplying until you get to the number that was given to you by n. So we can we can come up with the answer. Like, let's say I gave you 3 factorial. Give me a value of 3 factorial. It would be 1 times 2 times 3, which is 6. So it's very simple in concept. One thing to note though, 0 of factorial is defined by 1. So in any given factorial, the least possible value of any factorial would be 1. There's no 0, it's going to be 1. Where is factorial being used? I can think of algebra, probability, calculus, but there are many more topics, many more areas of in math, in statistics, in probability. I mentioned it again, but yeah, there are so many use in math. Factorial is everywhere. You can think of it that way. So let's do a simple exercise. Our goal is to understand, fully understand factorial of n. So let's do 6 factorial. It's 1 times 2 times 3 times 4 times 5 times 6. I'm not going to go into, getting the number like that, but, I'm pretty sure you as a, user of math can figure that out. Again, 7 factorial would be 1 times 2 times 3 times 4 times 5 times 6 times 7, which will give you a number, of course. But since we already had 6 factorial, what can we do? We can reuse the answer that we got from 6 factorial. And then on top of that, what do we do? You just multiply 7 to it. That's what your answer is going to be with the 7 factorial. Now, up until 7, yeah, it was kind of tedious, but I can do it. But when it comes to 30 factorial, do I want to do it by hand? Maybe not. So I'll, pull out my calculator and I'll do it that way. But even still, it's very tedious. You got to type in 1 times, 2 times, 3 times, all the way up to 30. But it's very easy in concept. It could be tedious when it comes to a big number factorial. So let's spend some time, like around 10 minutes, and then we'll come back and make sense out of it. Okay, so we found out factorial of n is pretty simple in concept and pretty easy to understand and carry out the task. And we also noticed that if the number becomes big, like 100 factorial, would you be able to do it by hand? Of course I can do it by hand, but it will take long time and it's very tedious. So as a human, we're prone to make a mistake. We're prone to make some kind of, very simple errors here and there. So when it comes to big numbers, you know, you really have to be careful working with Factorial, I guess. So our next agenda is to, make the Factorial of n into some kind of programming code in Java, so that when it comes to big numbers, like 100 factorial, I don't have to do it by hand. We'll just pass that number into my code. Voila, my answer is going to be popped out right there. Okay, and that's the power of computer programming. When it comes to repetitive and tedious, tasks, if we can come up with a programming, if we can come up with a solution with the programming, then it becomes really easy. Shorten the time, very efficient, and it's it's not going to make any human error like that. So there's the power of the programming. As always, I would like to have some kind of plan before I do that. So I'm going to start with, again, the flow chart. So here we go. The first step, we all know. Our first step is start with a circle. And then what I'm going to do is I'm going to again ask the user to give me a number, a positive integer number that will become n factorial, whatever that number is. So input is n, okay. And then the next step. This step would be somewhat new to some of you. I'm gonna set up, after all is done, what I'm gonna be end up having is answer, right? So answer, and I'm gonna initialize it with 1. The reason I initialize it with 1 is that any given n factorial, the least possible answer is what? 0 factorial is, I said, it's defined by 1. So any given n factorial, the least possible value for n factorial is 1. So I start with 1, but my answer can grow as, as the given n is different from 0. At least given n is not 0. It's going to grow. So I can take care of that later on. But I wanted to initialize it as 1. So before we move on, when I say answer equal to 1 here, it's like doing something like this. In the computer, behind the scene, what's happening is they have something like this. Some kind of table behind the scene. Just like when you go to a post office, you have a PO box there, and all the PO box has numbers assigned to it. So when I say answer 1, so answer is type int, and the name is answer. Then the computer assigns a box for it. So let's say it assigned my box here, and what's inside of it here is the value 1. Okay? And then whenever I refer to the answer later on, computer will know where to come. It will come to this box, and then whatever is in this box, it could be 1. Later on, it could be some different number, but it doesn't really care, because as long as I use this name, alias, a variable name, answer, it will give me a value inside of this box. Okay, so that way I can keep track of answer. I can make it bigger. I can make it smaller. As long as I use the answer, I can change the value in this box. Okay. So I have established the answer variable and initialized to 1. Now next, what I'm going to do, and this is a little bit tricky, so I'm going to explain it here. So when you are doing, let's say we are doing 4 factorial. What's happening in your brain when I ask you to do, please do 4 factorial. Give me an answer for 4 factorial for me. And then you will say, okay, it's a 1 times 2 times 3 times 4. Very logical in your brain. But how do you actually do it? Does your brain know to do this? What happens when you start here? You start with 1, right? And then why do you start with 2? Can you start with 3? Or can you do 5? How do you know you have to start with 2? In your brain, I think what's happening is 1, you start with times, and then the next number. What's next number? Next bigger number to 1 in integer. That's 1 plus the first number. So what's 1 plus this number? It's 2. Okay. And then you don't do it. You don't consciously do it, but your brain is doing it for you. Is 2 equal to 4, which is the end, right? No. Oh, then you can go one more time. So one more time is what? 2, 1 bigger than 2. So times 3. And then your brain is asking, is 3 equal to 4? No, no, no. Then, okay, you can do one more. So you add one more to 3 times 4 is 4 equal to 4. Yes. Then, oh, okay, that's it. That's all I'm going to do. And the answer is 6 times 4 is 24. That's how you do it in your brain. So how do I translate these steps into my code here? All right, so what I found out, for me, it's easier for me, instead of growing like 1, 2, 3, 4, it's easier for me to do it backwards. So in my case, 4 factorial, I do it like 4 times 3 times 2 times 1. What I'm doing is, okay, so n times n minus 1 times n minus 1 minus 1 times, go on and on until what? Until the, whatever I'm multiplying is bigger than, as long as that number is bigger than 0. Okay, that's what's happening in here. So what was happening here? So I start with the n, right, which is 4 times, and then n minus 1 is what? 3. And then I ask the question, is it bigger than 0? Oh yeah. And then n minus 1 minus 1 is 2. Is it bigger than 0? Yeah. And then n minus 1 minus 1 minus 1 is 1. Is it still bigger than 0? Yes. And then n minus 1 minus 1 minus 1 minus 1, which is 0, which is not bigger than 0. And then, oh, okay, I stop there. So I get the same number, 24. Okay. So I'm going to put this into my logic. So what I do is, if n is what? Bigger than 0. Then when you ask if this is rhombus or diamond. So if n is bigger than 0, if that's yes, I'll come here. And what do? I do answer is answer times n.